We're going to take a look at 10.7 part 1. This has to do with length relationships when two chords intersect. So here I have two chords, A, B, and C, D, and they're basically two random chords that I drew, and they're intersecting anywhere. So two chords of any length intersecting anywhere in the circle, okay? Now, the only information I have right now is that I have two congruent angles here. These guys are vertical angles. And really, there's nothing else I can do here to find the length besides measure it myself. But we're going to figure out a way to indirectly measure lengths of chords. Okay, so the first thing I'm going to do is draw an imaginary line here, AC, and I'm going to draw an imaginary line here, BD. And what I've done is I've created two triangles. Now, let's see if there's any kind of a relationship with these two triangles. Now, I want you guys to take a look at angle C and angle B, okay? Take a look at those two angles and see where they are in that circle. You might want to pause it to take a look. If you look really closely, you'll see that they are both inscribed angles. And not only are they inscribed, but they're both inscribed and intersecting arc AD. And because they are both inscribed and intercepting the same arc, we can conclude that angle C is congruent to angle B. Now, for the same reason, I can conclude that angle A is congruent to angle D because both of them are inscribed angles and they are both intercepting arc CB. So angle A is congruent to angle D. What I'm going to do is I'm going to name each of the sides by the lowercase letter. So this would be A, this would be C, D, and B. Again, if you don't remember why I'm doing this, opposite angle names the opposite side. So if the angle is B, the opposite side is little b. Okay, so now I have two similar triangles because their angles are congruent. And when I have two similar triangles, their sides are in proportion. So let's compare the little triangle to the big triangle. So little triangle, big triangle. Now, if you take a look at the little triangle, I'm just going to randomly write A over C. You could have written C over A. It really doesn't matter. Now, A is opposite the fuchsia, or angle A. And angle A is congruent to angle D, right? So therefore, A and D correspond. So because I have A on top for the little triangle, I need to put D on top for the big triangle. For the same reason, since C is on the bottom for the little triangle, B needs to be on the bottom for the big triangle. So here I have a proportion. A over C is equal to D over B. Now, I know you guys are going to ask, so I'm going to do this another way. Okay, let's say I was, instead of comparing little to big, I was comparing the same sides. Let's do red side versus fuchsia side. I do not know how to spell fuchsia. I am probably misspelling it. All right, so the red side would be C over B, right? C over B. Now notice this is the little triangle and this is the big triangle, right? And the fuchsia side would be A over D, okay? So again, this is little and this is big. So there are lots of ways that you can set this proportion up. So the way that I set it up originally is not the way you have to set it up. Um, Lots of ways to set it up. Okay, so what's the point of all of this? Well, if you cross multiply now, okay, if I take that and I cross multiply, I'm going to get AB equals CD. Well, what's going to happen if I cross multiply these guys? Well, I'm going to get CD equals AB. And notice that I've actually written the same thing. AB equals CD, CD equals AB, same thing. So what have we done here? We have shown that if you have two intersecting chords, right, that A times B is equal to C times D. Okay, so if you have two chords intersecting in the middle of nowhere in a circle, then the pieces A and B, if you multiply them, you're going to get the same thing as if you multiply C and D. Okay, and we know this because we just proved that you can make similar triangles and that the sides are in proportion. All right, so here we are on the notes, and notice that once again, the equation, when two chords intersect, if we're looking for the pieces of the chords, A times B equals C times D, okay? All right, let's start with number one. We have to find x, and we're going to round to the nearest tenth if necessary. So number one, we would do 3 times 6, because these are the two pieces of that chord, equals 2 times x. And then when you solve it, 18 equals 2x, x is equal to 9. Okay, let's move on to the next one. For number two, we have a little bit of missing information. We don't know what this piece is right there, but notice that the entire radius over here is 10, which means that this piece has to be 8, because that's 2, and then plus 8, that gives us 10. So I know that that piece is 8. So I'm going to put a little 8 in there. Okay, so when we do this, we have x times x, or x squared, is equal to 2 times 18, because this entire piece is 18. Okay, and the 2 I'm getting from there. So I have x squared is equal to 36, and then the square root of 36 is 6. And that's your x. All right, let's go on to number 3. I have 8 times 8, which is 8 squared, is equal to 6x. That's 64 is equal to 6x. Divide each side by 6, and that gives me 10.6 repeating. So x is equal to, and I'm rounding to the nearest tenth, so that's 10.7. Right, I'm going to move on to number 4. Number 4 says 3 times 6 is equal to x times x plus 7. And we're going to end up with a bit of a quadratic equation. 3 times 6 is 18, equals x squared plus 7x. Now, when you have a quadratic equation, you have to set it equal to 0. So I'm going to get 18 over to the other side. So x squared plus 7x minus 18 is equal to 0. So we need to factor this guy. All right, so let's think of two numbers that multiply to give us a product of 18 and a sum of 7. You might want to pause the video to think about that. Okay, and I'm going to move on. The numbers are 2 and 9, and one of them needs to be negative. Since our sum is 7, the 9 needs to be positive, and the 2 is negative. So we have x minus 2, x plus 9. Again, negative 2 times positive 9 gives us the negative 18, and negative 2 plus positive 9 gives us the positive 7. Okay, if you have any questions on how to do quadratics, please contact me. Okay, so then what would make x minus 2 0? That would be x is equal to 2. And what would make x plus 9 0? That would be x equals negative 9. Now, looking at the shape, if I plug a negative 9 anywhere here, I'm going to get a negative answer. So because I'm going to get a negative answer, I am going to throw out negative 9 or reject it because it's not a possible answer. So my x is therefore just 2. Okay, I'm going to move on to number 5. I've made the screen a little bit bigger. Okay, so here we have a 5 and an x plus 2, and I don't know what to do with this. Or maybe I do know what to do with this. If you take a really close look, this right here is the center. And since that is the center, all of these pieces, this piece and this piece and this piece and this piece, they are all radii. So they have to all be congruent to each other. So in this case, all you have to do is say x plus 2 equals 5 because these are just radii. And so therefore x is equal to 3. All right, so here I am on number 6. Now, number 6 is a little bit tricky, so you have to figure a few things out. First of all, I have a radius right here, okay? And that radius is perpendicular to a chord. Now, remember, whenever you have a radius that's perpendicular to a chord, it also bisects that chord. So since this piece right here is x, the other side is x as well. So let me erase all that, and I'm going to put an X right here. The other thing is, I don't know how much this piece is right there, but I do know that the entire radius is 7. Since the radius is 7 and the little piece right here is 2, I know that the other piece of this is 5. So let me erase this and make this nice and neat. So here we have X, here we have X, and here we have 5. Okay, so those are our pieces. So on the one side here, I have a 2, and then on the other side, I have 12, 5 plus 7. Okay, and for the other chord, I have x times x, or x squared. That gives me 24 is equal to x squared. Take the square root of each side. So I'm going to go on the side and do 24. So that's 6 times 4, 2 times 3, 2 times 2. We're going to have a pair right here, and these two guys are going to be on their own. Okay, so you can just skip to 2 square root of 6. This is the 6, and that's the 2 that stays on the outside. Or you can do it like this. Square root of 4 times square root of 6 is equal to x. Square root of 4 is 2. Square root of 6 cannot be simplified. So that's how you get 2 square root of 6. So that's the value of x. All right, for the next one, we have 6 times 5 is equal to 2x times 3x. Okay, 6 times 5 is 30, is equal to 6 x squared. When I divide each side by 6, I get x squared is equal to 5. And when I take the square root of each side, I get x is equal to square root of 5. And finally, number 8, I have 8 times 6 is equal to 3x times x. So that's 48 is equal to 3x squared. Divide each side by 3. So x squared is equal to 16. Therefore, oh, this is an easy one. X is equal to 4. All right. I hope that this was helpful. Please let me know if you have trouble on the homework. Let me know, email me or whatever you normally do, and I will help you out. All right. That's the end of 10.7 part 1. Hey guys, I just wanted to add one more thing. I think I forgot to round to the nearest tenth, so I'm just going to give you the numbers. For number 6, you should get 4.9, and for number 7, you should get 2.2. Okay, so I don't think we did it to nearest tenth. I did it to the simplest radical form. But those are the numbers you should get.